everyone, we're going to find the absolute max and minimum of f on the given closed interval for f of t, and the closed interval is from 0 to pi divided by 2. So that's quadrant 1. Basically, we're looking at the absolute max and min. So we're going to use the closed interval method to find our values, and the first step is to find the critical numbers of f in our open interval AB. So basically, we have to take the derivative for critical numbers. So f prime of t, now the derivative of 2 cosine of t is negative 2 sine of t, and the derivative of sine of 2t is cosine of 2t, then you multiply it by 2. Now, I'm going to simplify this. I want to write everything in terms of sine. So this is going to equal negative 2 sine of t. And I'm going to write this my double angle. So I'm going to bring the 2 up front and write this in terms of sine using my double angle identity, which is 1 minus 2 sine squared of t. Now, I'm going to factor this so we can find the values. And I'm going to take out a negative 2. Now, if I take out a negative 2, this is going to turn to positive. So that's going to be 2 sine squared of t. This is going to be positive because that was already negative. So it's plus sine of t. And I put out a negative. This is positive, so that's now going to be negative 1. All right, now let's factor some more. And you factor this, you get 2 sine of t minus 1 times sine t plus 1. And you set this to 0. We don't really need to look at the negative 2 here, so just set this to 0, and you're going to get, if you add 1 to both sides, you get 2 sine of t equals 1. So sine of t equals 1/2. And if t is 1/2, and you have to do this quadrant 1 here, that means t is pi divided by 6. For this one, you're going to get sine t equals negative 1, so that would be t equals 3 pi over 2, but that's not in our closed interval, so we have to disregard that one. So our critical number is pi divided by 6. So the next thing we need to do is step 2. Step 2 is to find the endpoints of the interval, and we're also going to have to remember t is pi over 6. Let's go ahead and do that one first. So we're going to have to evaluate f of pi divided by 6. So that's going to equal 2 cosine pi divided by 6 plus sine of 2 pi, so that's going to be pi over 3. And this is going to end up giving you cosine of pi over 6 is square root of 3 over 2, so 2 times square root of 3 divided by 2 plus 1/2 square root of 3. Now these two cancel, so when you add these two up, you're going to get this equals 3/2 square root of 3, or 3 square root of 3 over 2, which is approximately 2.60. Now, for number 2, we're going to test these endpoints. So we're going to do f of 0, which equals 2 cosine of 0 plus sine of 2 times 0 is 0. This is just 0. This is 1. So f of 0 equals, let's see, where are we? F of 0 just equals 2. And then we have to check pi over 2. So if you put in 2 cosine of pi divided by 2 plus sine times 2 pi divided by 2, this is going to give you 0. Because sine of pi is 0. So this is 2 times 0 plus sine of pi is 0. Now we can look at our smallest amount and our largest. So for step 3, our absolute maximum is the largest value, which is 2.60. So our largest absolute maximum is f of pi divided by 6 equals 3 square root of 3 divided by 2. And our smallest value is the 0. So f of 0 equals 0, and that is your absolute minimum. And that's it. Thank you. Have a nice day.